Antenna polarization here, it's also very important. So if you have the same antenna polarization, for example, like that way, then we have a very high signal. If you have the wrong polarization, like for example, I do this one with my body pack to the receiver antennas here, in that case, I lose maybe 20 dB on my signal level. So in this case, if I would like to use here the antennas in front of the receiver, it's a good idea to put them to a 45-degree angle that I cover nearly both sides, because nobody knows what I'm doing with my hand like that way. I do that way, I do that way, I do that way all that time. So then it's a good idea, if you're using small antennas like this one, to put them in a 45-degree angle, that you cover nearly both sides. Antenna high, minimum 2 meters, that you are coming over the people. Remember, free side of line. Unwritten rule for radio microphones, all time, if possible, free side of line. Like for example, if you know that you are doing a musical theater or something like that, and all the people, they are using body packs, maybe here in the backside or maybe here somewhere, it's not a good idea to put the receiver antennas at the front of house desk, maybe 30 meters away, because then you have the body absorption effect. So then it's a good idea to put the antennas from the side or from the top, but not from somewhere over there, where the people can stand, maybe also like an audience like here, for example. Because you are sitting now, but you stand up and we put the antennas like on this high, then we have the body absorption effect. And this is the effect, what I can do here. If I'm going a little bit far away, I'm holding down the antenna. So I would like to see if I'm running into dropouts, if I'm going a little bit here. Now it's still stable. It's stable. It's stable. It's all time stable. So we have here very good working conditions, all time also stable. But it can happen that you have only 10 or 15 meters in that case. So all time free side of line, if possible. For in-ear it's very important, because the receivers, like that one, it's non-diversity. You have all time only a non-diversity system. So this is the reason why you are using mostly directional antennas on stage, that you have a little bit more gain, and you need this power that you can cover the same range as he's walking, or the artist is walking with his wireless radio microphones. But on in-ear systems, you are running much more easy into dropouts than with radio microphones. And this is also the reason why some productions are using helical antennas with a very small beam on stage. Maybe you saw them also on a huge stage. They are looking like a long tube, and they have a very, very small beam. And the coverage is very, very small. Because if you have artists on stage, like, for example, Shakira or Bruce Springteen, they would not have dropouts on the in-ear systems. Because otherwise you can search for a new job on the next day, if they have 2 dropouts on their in-ear systems. So you have to take care for the in-ears that you have a very good antenna position. Because non-diversity all that time.
Aunque hay unos ahora que tienen 2 antenas, pero realmente el sistema de True Diversity del in-ear no es muy efectivo, porque están las antenas muy cerca. Entonces, si tiene una sola antena, es non-diversity. Si es 2 antenas, pues es True Diversity, pero con las antenas muy cerca.
So the next point, what we have, the RX antenna have to be at least 1.5 meters away from each transmitter. Because there can be the situation, if I'm going close with my transmitter, like that way, I overdrive the system. Because in that case, I'm very close, high power output, like my antenna from here. And then I have the situation like it can happen, for example, if you have a radio transmitter power station who transmit radio station number 1, for example, and you go by car under this transmitter and you would like to hear radio station number 2, not the radio station number 1. And what happens? You don't find other radio stations because this transmitter is coming in with high power inside your car radio, and the radio is getting a kind of blind. So you overdrive the internal input stage of the receiver. So that's the reason why it's not a good idea if you can have the situation that you can go very close to the receiver antennas. For example, if they are on stage, or on the side of the stage, and you have a stage height like this one, and you put the antennas in this high, and I have body pack here, and I can stand there. That's not a good decision to make that. If this can happen, you have to look for different antenna position, because the other transmitters can be on stage, maybe 20 meters away, I don't know. But if I'm doing this, I'm high powering in to my receivers, and the receivers are getting blind, so I increase all the levels with my transmitter. Interference product and also my transmitter. And maybe there can be the situation that the receiver is getting blind in that case. So this is the reason why you have to take care that you are also a little bit away, like 1.5 or 2.5 meters from your transmitters, like also the in-ears. So this gives you only idea, this is my transmitter. Like we are receiving here the measurement with this one, with the omnidirectional one. So I'm maybe 1 meter away, like that one. So we are here at minus 50 dB. This is the minus 50 dB line, where we are now. And now I go a little bit closer, and you see what happens. Yes. You see what happens? Now I'm overdriving my input in that case. And this can also happen for the wireless radio microphones with the receiver. This is the effect. And you see how much we lose on the first meter. And if I'm going away, it's like that one all the time. But on the first 2 meters, that's very important, we lose a lot of level. So and if we have, in that case, directional antennas, we have another 5 dB gain in the front. So we add some more. This is an omnidirectional one, so we're adding nothing. Far away from some metal effects, also metal objects here. That's also very important, that you have no huge metal objects around the antennas. And another problem is now occurring from the light guys if you are using LED walls. That's the worst case on stage if you have a lot of them, because they are coming very wideband with wideband noise. The first ones, they start in the area between 700 and 800, but the new ones, they are now going down also to 500. So we have a worst case scenario, for example, if this is our LED wall and you would like to put the antennas over there and you would like to run 80 channels. You have to absolutely take care where you put the antennas, and in that case, like we have here, for example, that our screen here is our LED wall, it can be a good solution that you put the directional antennas in front of that, like this one, that you fade out all the noise coming from the LED wall, that you are coming from the back here to the stage and not from the side. It depends from the situation. It can be a good solution to do it in this way. Other kinds of problems can be, for example, stage tracks from digital desks, for example, like that one. Remember, if we are close, like you put the stage track in directly under the receivers, or some other kind of digital stuff like, for example, digital amps. They can distort also the system, but then we are talking about interference products. They are coming from the distance, like if you are close to the receivers, that they are going maybe into the display or over the connectors inside the box, and then you are building inside interference products. So we are transmitting all time with less power than all others, like Wi-Fi. Wi-Fi can be 500 milliwatts. We are transmitting with the highest power of 100. if it's allowed country-wise. Mostly 50, between 20 and 50. So we as the manufacturer, all the radio wireless microphone manufacturers, we are transmitting with less power than all other equipment, like weather stations. If you buy a 800 megahertz weather station, it's transmitting with 500 milliwatts. We are transmitting with 50 or 20. So we are at the end of the row from everybody. But you have to take care about small things if you set up a wireless system. Then you can be mostly sure that it works well all the time. That's very important. We are using here remote antennas with remote cables. That's also a very important point, and we can have influence on the cables. It depends what type of cables we would like to use. And you see here a small list for the VHF area around 200 megahertz and in 800 megahertz. And we talked before also about the ability, how much the cable loss is for VHF and UHF. And you see here, for example, the RG58, the worst case cable we have here for the in-ears. It's a cheap one, but you see also we are losing a lot of dBs on 100 meters. Nobody uses 100 meters on stage, but if we have, for example, 10 meters, we lose 5.1 dB. And in that case, that we are using RG58 as an in-ear, it's not possible to use here an amplifier. So I lose here on this way, between the transmitter and the antenna, I lose 5 dB. If I'm using a 10 meter RG48, and it's not possible that I boost the signal here. So I have less signal coming out from here. The standard here from the transmitter, also from our transmitters, is that you are coming nearly with plus 12 dBm out from here. And if I lose here 5 dB, I have only nearly plus 5, plus 4, depends. But this is what I lose here. So for in-ears, it's very important. Also for the receivers, it's also important, but for the in-ears more, because it's not possible to boost the cable here. Use less cable as possible for in-ear systems and good cables, because all the signal you lose, it's gone. There is no possibility to bring it up again. All these cables have to be 50 ohm. For RF radio microphones, all time 50 ohm, no 75 ohms. Otherwise you have a different impedance, you lose a lot of signal. That's also very important. All time 50 ohms, please. Okay, better cables is the RG213, Erzl 7. What we are using here, for example, it's 7 millimeter diameter, so it's a very strong cable. But you see here what happens. You have minus 18 dB on 100 meters in the UHF area. So this is a range what you can boost, for example, with active antennas, or we see it on the next slide with an antenna booster, with an external antenna booster. This is in the range, for example, if you use 25 meters, you have nearly around 6-7 dBs what you have to boost, but not like 20 or 30. Because we are fighting for every dB we can have in the sensitivity for our receivers. Remember that. So on this slide you see what happens with the signal. If we lose, for example, 6 dB, we have 50% of our signal quality is gone. We are talking only 6 dB. That's nothing. But then I lose 50% of my signal quality from my radio microphone. So this is the reason why we are using boosters if we are running remote antennas, like boosters inside the antenna called active antenna, or we have some external boosters like that one, for example. It's a very small one, it's switchable in that case. So the boosters, they are powered from the receivers via phantom power coming over the antenna signal then. And here we have a switchable one with 5, 10, 15 and 20 dB. And very important, the boosters are used to boost the signal from the antenna over the cable. So that means I would like to boost only the cable loss. I'm not boosting my sensitivity of the receiver. If some people think if I switch it to 12 dB, I have better sensitivity, I can go a little bit far away with my handheld transmitter. The booster is only to bring the cable loss up to the receiver and not for better signal quality coming from the antenna. Maybe we can show you what happens here. I'm running out of the signal. Not really. So I would like to switch here the 12 dB. Wait. Now in 0. Now do it to 12. So normally you can see also that the noise floor is coming up from the rest. So we are running here only 10 meter cables, good cables. That means we have 2 or 3 dB less. So it makes absolutely no sense to use here 12 dB or 6 dB. So we can go here with 0 in that case then. So that's also a very important thing for you. Only use boosters or active antennas to boost the cable. If you're running 5 meter cable, don't use the booster or use the +6 or +10 or +15 on an active antenna. Less level is mostly better than high power or high level all that time. So we saw this picture a long time ago. As I told you before, reduce the antennas as much as you can. Here, use less antennas as possible. Also for the in-ears, we are using here a combiner inside for the transmitters. That means we have 4 transmitters. They are going to a combiner. We have 4 inputs and 1 outputs to the antenna. Then, in that case. Some other rules here. Keep antenna cable as short as possible, especially for the in-ears. For the wireless radio microphones, you can boost it a little bit. But for the in-ears, you lose everything what you lose on the cable, you lose on stage. Use good cable here all the time. And also use active antennas if you use remote antennas like we have here on stage. How to manage multi-channel systems. In that case, it's very important that you use, if you use premium systems, that you use the pre-programmed frequencies from the manufacturer all the time and not doing shows like adjust the frequency like, for example, 500 megahertz, the next one to 501, the next one to 502, over next to 503, that you have only 1 megahertz. You are not on a safe side if you are doing that one. Because you don't know, you saw what happens with all the interference products and you don't know where they are. Maybe you are running into trouble. If you put the 6th or the 7th frequency, then the full system is not working. So use all time, if possible, pre-programmed groups here inside from the different manufacturer or from the pre-programmed sheets they delivered from the different manufacturer. Then you have to be sure that you are on the safe side with your radio microphone systems. Then I know that there can be a lot of different situations where you can run into. You do a sound gig coming as a mixer and then each musician brings his own wireless stuff. And nobody takes care about that. You have 5 wireless radio microphones on stage. The first one is a Shure, the next one will be a Beyerdynamic, the over next one will be a Sennheiser and so on. And you don't know what happens there. And all the musicians, they are not taking care because they are putting out their stuff, put it on the amplifier and switch it on and go. So I know that there are different situations you can't handle. But if you run, for example, a huge system on the other side that you have to take care about 80 channels. So sometimes you have to make the decision It depends from the bandwidth you can use, but sometimes you have to make the decision that you have to say, hey, the drummer don't need his wireless microphone because he's sitting all time. You have to take care about the channels, and sometimes less channels are much more safe than you would like to have all of them. The bass player standing in front of his amplifier, the keyboard player, don't need an in-ear system, maybe a wireless one. Maybe you can use a wired one, also for the drummer. Also, wireless microphone for the keyboarder. He's sitting behind his instrument. You can use a wired one. So sometimes it's better to reduce the list of the radio microphones to have less frequencies and more space for the rest, more security for the rest on stage. To handle such huge things, it's better to use the software like the Shure Wireless Workbench or the Sennheiser Frequency Manager, that you can calculate different frequencies for different brands maybe also, or for in-ears or something like that. And there's one thing for the programs, for the software programs, because they use not all the same parameters to calculate the frequency, because, for example, the Shure is putting the frequencies in nearly the same distance inside the bandwidth. Sennheiser does sometimes calculating more frequencies into less space, but then there is a block coming with all the interference products. So that's a little bit different. So sometimes it's better to use this software or to use this software. It depends what you can use in the frequency range. If you have, for example, some digital TVs in a row like 24 megahertz and you have only 30 megahertz, then sometimes it's better to use the Sennheiser software than the Shure software, because you have more frequencies then in this 30 megahertz band than the Shure calculates in. Shure calculates maybe in 15 and the Sennheiser will be 19, only for example. Then. So they are working with different calculations inside the program. So that's only for the knowledge. So all time, if you're running a lot of wireless systems, take care that you have in the modulation-free frequencies for your in-ears and for your wireless radio microphones.
No, ¿alguna
Yes.
pregunta de dos? What is the maximum quantity of system that you can use with 2 antennas?
It doesn't matter. The antennas doesn't matter. If you can handle 300 channels, that's not a problem. But it depends how you connect the receivers then to the 2 antennas. So in that case, if you have, for example, 2 weeks ago there was a Eurovision Song Contest. It's a huge TV show across Europe. They are looking for the new star from Europe. With 500 million people watching this show, it's the 4th biggest show around the world. And they are running there nearly 320 channels wireless radio microphones. Not all on the same time, but all together there are nearly 320 channels. Like a lot of in-ear systems, talkback systems, and also radio microphones. And they would like to reduce also the antenna as less as possible, but there are 12 or 14 pairs of antenna from different directions to cover different areas. Because there's a huge backstage area where all the artists are sitting. There are 26 or 28 artists, and it's an open backstage area, so they have to use the in-ear systems there, also the wireless radio microphones there. So you have to cover a huge area. And it doesn't matter how much receivers you would like to connect there. And as less antennas, then you're fine. So sometimes there can be the situation that you have to use band filters for the system, that you fade out the rest. Then you put some band filters directly to the antenna. For example, we are running here a wideband system, like 320 megahertz. We are picking up everything. Like in 600 megahertz, also in 470 megahertz. So we are picking up everything here with our system. So in that case, if you would like to have many, you have to select sometimes also band filter. They are going with a filter like that one and not like that one. So you can fade out all the rest of the noise for different systems. So there is a physical limitation for two antennas.